In this video, I want to take a look at a trig substitution integral with a definite integral and show you an option that you have here, or how it's a little bit different than the option that you have with u substitutions. Anyway, let's take a look at this one. I see the 1 plus x squared here. That reminds me of tangent, because 1 plus the tangent squared theta is the secant squared theta. So that 1 plus in there makes me think I want to let x equal tangent theta. So dx then has to be the derivative of that, secant squared theta times d theta. And substituting in, what do I have now? I've got an integral. This is a 1 plus tangent squared theta, that whole thing squared, and then there's a 1 on the top, and the dx is secant squared theta d theta. Now, the limits of integration here are the thing that I want to take a look at. Yeah, we'll finish this integral as well. But with u substitutions, you had two options. One is you could just essentially ignore the limits to begin with, do the integral, switch it back to x's, and then plug your x values in. Or you could have, and we did this on occasion, convert the limits of integration as well, so that after you do the integral in terms of u, you don't have to go back to x's. So that's what I want to try to do here, is to do this. The thing is, in the u substitution, you had u as some function of x. On this one, I have x as some function of theta. So when I say 0 here, 0 is the x value, and 1 is the x value. So I'm looking at this saying when x is equal to 0, I got to figure out what theta is. That tells me that 0 is equal to the tangent of theta. So theta is the inverse tangent of 0, which it turns out happens to be 0. Likewise here, if x is equal to 1, then that tells me that 1 equals the tangent of theta. Right? I'm just plugging it into my substitution. Figure out what theta is. Well, theta is the inverse tangent of 1, which is pi over 4. So this integral is going to be the integral from 0 to pi over 4. Now, sometimes it's not worth your while to do that. Sometimes it's just, well, let me just do the integral and get it back to x's. But I think on this case, it actually will be distinctly worth our while, because what happens here is I've got that secant squared theta on the top. The bottom is 1 plus tangent squared. That's secant squared squared, so it's a secant to the 4th theta on the bottom. Right? So you've got, and that's the integral from 0 to pi over 4. So this is 1 over secant squared, but 1 over secant squared theta is actually the cosine squared. And the cosine squared theta is like sine squared theta, which we did in another one of the videos. You got to use a power reducing formula. This looks like the integral from 0 to pi over 4 of 1 plus the cosine of 2 theta, over 2 d theta. So you end up with 1/2 the integral from 0 to pi over 4. Well, let's just do the integral here, right? 1/2 goes out in front. The integral of 1 is theta. The integral of the cosine of 2 theta is equal to 1/2 the sine of 2 theta. Right? Now, what we saw before, whoops, not plus c, this is a definite integral we're evaluating between 0 and pi over 4. What we saw before was that to get this back into x's, you got to do a double angle formula for sine, then draw that triangle and whatnot. But having switched the limits now to 0 to pi over 4, so these are limits on theta, you can just plug them in. You can just say, okay, this is 1/2 pi over 4 plus 1/2 sine of 2 pi over 4 minus 1/2, plug a 0 in, 0 plus 1/2 sine of 2 times 0. Anyway, so you've got pi over 8 plus 1/4, and this is the sine of pi over 2. Sine of pi over 2 is 0. Huh, okay, and this is all 0. So you're looking at pi over 8 for your solution, okay? The converting the limits is similar to what you did with u substitution, except that you're plugging in a different place. With the u subs, you knew what x was, you plugged it in, you calculated u. Now the thing is, you know what x is, it goes in here. You got to work that inverse tangent in this case, or inverse sine or inverse secant, whichever one you're using. In this case, it's tangent, to figure out what those angles are that you're using for theta. Okay. So there's use trig substitution with definite integrals.